which occurs when a substance X is converted from liquid to vapor phase at the standard boiling point. Okay, we know that the standard boiling point, what happens at that? The temperature remains constant and the liquid gets converted to vapor at the same temperature. For example, when we have water at its boiling point, that is 100 degrees Celsius, what happens? There's an equilibrium between the vapor phase and the liquid phase, and the temperature remains constant at 100 degrees Celsius until completely water is converted to its vapor form, right? So the first option says potential energy of the system decreases. We cannot really say that. The potential energy of the system nearly remains constant. Why? Because the potential energy is something which has to do with the intermolecular interaction. And while boiling, it remains similar. Second, the distance between the molecules increases. This is very true because as liquid moves into the vapor phase, the molecules start moving away from each other, and so the intermolecular distance would increase. The third statement is that the average kinetic energy of the molecules in both the phases are equal. Now remember, we had said that during boiling, the temperature remains constant. And according to the kinetic theory of gases, the average kinetic energy is 3 by 2 kT, right? So the temperature is constant, therefore the average kinetic energy has to remain a constant. Therefore, statement C is also correct because both the phases are at the same temperature, and so the kinetic energy of the molecules in both of them would be equal. So the only statement which is incorrect is statement A, and so your answer becomes D. That is 2 and 3 only are the correct ones.